We're going to look at IP version 4. IP version 4. What is an IP address? An IP address defines a node. What we mean by a node is just an interface on a network. It's just an interface, maybe on a router. It's just the interface that you're using to connect to your switch, that interface on your computer. Therefore, the IP address is used to identify a node on a network. IP addresses are used to forward IP packets. Take note of this. IP is a routable protocol. What we mean by routable protocol, it alone is not enough to have communication. You need a protocol to transmit it. You need a protocol to transmit it. You need a protocol to transmit it. Now, this is the notation. When you talk about IP version 4, it is a 32-bit number. It is a 32-bit number. Now, I'm going to say something strange here. If you did not take time to actually do the conversion from decimal to hexadecimal, or from decimal to binary, you might get confused the most if this is the first time you're seeing this. Therefore, if you didn't, make sure you're very attentive. You've actually chased away everyone close to you. But if you did, pay more attention so that you understand more. Now, an IP address is a 32-bit number. It is divided into 4 octets. It is divided into 4 octets. Each octet has 8 bits. Each octet has 8 bits. Each octet has 8 bits. There are 2 ways we can write an IP address. We can use the decimal format, that is base 10, or you can use the binary format, that is base 2.
Base 2.
In base 10, we only accept numbers from 0 to 9. In base 2, we accept only numbers from 0 to 1.
0 to 1.
Now, this conversion is straightforward. We all know very well. We all know very well that our octet, or each octet, contains 8 bits. It contains 8 bits. Now, you come and actually have 8 spaces. These 8 spaces here. And then the first bit from your right, I believe it is your right on your screen. From your right, yeah, you give it a 0, 1, 2, 3, 4, 5, 6, and 7. These are the placed values for the 8 bits we have in an octet. Now, in the first octet, it is the same as 2 power 0, which is giving us 1. 2 power 2, 2, 4, 8, 16, 32, 64, 128.
128.
Now, how do we convert these numbers to binary? That is the question. Now, this is the simple way. I don't know which way that you know, but this is the simplest way. After listing these 8 bits places for each, you have 128, 64, 32, 16, 8, 4, 2, and 1. We are going to convert 192. We are going to convert 192 to binary. For us to convert 192 to binary, we find the number in this that is closest to it. We find the number in these that are stated that are a power of 2 that is close to it. Is 192 close to 128?
Yes.
Yes.
Is it close to 64? This is very far. It is close to 128. We turn on that number. But remember, 192 is greater than 128. We are going to subtract 192 minus 128. What will we get?
64.
64. 64 is close to which number or equal to which number? 64 is itself.
68.
Hey, you're adding the numbers. Therefore, we are going to turn on these numbers. So we are going to turn on 64. And then turn off the rest of the numbers. Why? Because when I add 128 plus 64, I get 92. In simple terms, in logical terms, you're going to add these numbers and see which numbers can I add to get this particular number. Which numbers can I add to get this particular number? Starting with the biggest number. You start from your left. For example, that was 192. If I want 168, if I want 168, 168 is greater than 128. Yeah, I'll make sure for me to get 168, I need to have 128 put on. When I subtract 168 minus 128, I'm left with 40.
40.
40.
It means 40 is much less than this. I skip it. I skip it. But 40 is slightly greater than 32.
32.
I turn this on plus 32. It means I'm left with 40 minus 32 that is not catered for. 40 minus 32 is 8. And the 8 is right here. I add my 8. When I add these three numbers, I will get 168.
8.
Therefore, if I want to write 168 in binary format, I'll turn on 128, turn off 64, turn on 32, turn off 16, turn on 8, and turn off the rest.
8.
And turn off the rest. Rachel, your hand was up. Rachel, your hand was up. Rachel, your hand was up. Hey, she has gone. Okay.
Here, no, I'm right here. Alex, can you hear me?
Yes, please.
Please repeat for me how we turn the 128, the 64 to 1. I skipped a little bit there.
How we turned the 128 to 1? It is simple. Number one.
Yes.
The bits that are used to add or to come up with a decimal number are turned on. The bits that are not used to turn, as in to get that number, are turned off. How do we turn them on? By changing it to 1 or by making it 1. We turn off by writing a 0 under that bit. By writing a 0 under that bit. For example, we are saying for us to get 192, we are adding 128 plus 64. It means these two must be turned on. That is why you have 1 and 1 here. For us to get 168, we need to add 128 plus 32 plus 8. Therefore, we need to turn on the place value. Where 128, we turn it on. Where 32 is, we turn it on. Where 8 is, we turn it on. And we turn off the rest of the values. If we want 10, for example, for us to get 10, 10 is less than equivalent to 8. Therefore, it means for us to get 10, we need 8 plus 2. We turn on 8 and 2. We put off the rest of the bits. Now, someone whose hand was up, actually it's still up. Abdul.
Yes, sir. Can you hear me now?
Yes, I can hear you now.
For me, I have my method where you can divide by 2.
Yes, I know that method is there, as long as you're getting similar answers.
Yeah, because from my, I look at that one like as if it is simpler than that one.